Welcome to Math TV with Professor V. Here is your integral of the day. I picked out an indefinite integral of e raised to the cube root of x dx. Now I've done one kind of similar to this before. It was e raised to the square root of x dx, and I don't know if you remember it or not. But if you do, it would be helpful because our approach for solving this integral is pretty much exactly the same as what we did for that one, which only goes to emphasize my point that I always tell my students, just keep practicing solving problems. That's how you get better at pattern recognition. Okay, so basically what we're going to do is a u substitution, and then it will require integration by parts. Since I already know that, I don't want to waste the variable u on the u sub. I want to save it for by parts. So I'm going to say let's let t equal the cube root of x. And before I find dt just like this, I'm going to make life a little bit easier for myself and cube both sides. So you could differentiate now, or you could say t cubed is equal to x, and now I'll differentiate. It's going to be a lot cleaner, no fractions, and you get the same result. So then 3t squared dt is equal to dx. So let's see, we should be ready to roll, because t is cube root of x, so I could just swap that out. And then 3t squared dt is my dx. So it looks like we're in business. That was pretty painless. Our new integral is going to be e to the t times 3t squared dt. Now, normally, I would say, okay, we want to take this constant, put it outside, and then work on evaluating the rest of the integral. But I can already tell we need to utilize integration by parts because I have an exponential function and a polynomial function. Okay, and the other thing I'm noticing is it's going to require more than one iteration of integration by parts because this polynomial is degree 2. If I just had t to the first, one round of by parts would take care of it, but squared means 2 rounds, cubed would be 3 rounds, etc. So when this happens, I like to do tabular integration by parts. And if you aren't familiar with the tabular method, I'll link a video in the description. I'll try to link it here in the top right where you can see some extra examples, but it's not hard. I could just show you right now and you'll be fine, believe it or not. So let's do tabular. You set up one column where you differentiate part of the integrand, and then the other one where you anti-differentiate. So in this case, since I have a polynomial and exponential function, the polynomial is going to go here in the column where I keep differentiating because I want to eventually hit 0, and that's when I know to stop taking derivatives. This is never going to hit 0 if I keep taking derivatives. So usually we don't put that in the first column. I said usually. Go watch the video. There are some cases where you might. And then the anti-differentiation column will have e to the t. Okay, so let's start taking derivatives. Derivative of 3t squared is 6t. Derivative of 6t is 6. And then keep going. You got to hit 0. And then since I have 4 entries, 4 rows, then you just fill in the other column the same number of times. Okay, so that basically tells you your stopping point. And then you draw arrows stacked kind of on the diagonal. So from the left column to the right column, but down a row. And that's going to tell you the terms to multiply together. The first one, you always keep the same sign. Then the second product, you're going to change the sign, and it alternates like this. So then it would be plus, minus if it kept going. You ignore the last entry. It's just a 0. And then that's pretty much it. So now we're done with this portion of the antiderivative, and notice we're going to have, so this product here is 3t squared e to the t, and then I'm going to have minus 6t e to the t plus 6 e to the t plus c. Okay, a couple things I'm noticing. I can factor out a 3 and an e to the t, so let me do that. 3 e to the t, and then I'm just left with t squared minus 2t plus 2 plus c. And then now we have to go back. Remember, originally t was equal to the cube root of x, which is the same as x to the 1/3. So I'm going to go replace that here. So we have 3e. You could put cube root of x or x to the 1/3. Do you have a preference? I'm going to write x to the 1/3. And then t squared would be x to the 1/3 squared. So that's x to the 2/3 minus 2x to the 1/3 plus 2 plus c. And voila. That is your integral of the day. If you're wondering about why are there alternating pluses and minuses, this tabular thing, I feel a little uneasy about it, then go watch the video I made on it. It's not too long. You'll like it. And I'm off to ballet class. I have a pas de deux workshop too after my normal technique class. So that should be interesting. I hope everyone has a fabulous rest of your day. I'll catch you guys soon. Give the video a thumbs up. Subscribe if you haven't already, pretty please. And you can also follow me on Instagram and TikTok at Math TV with Professor V. Join my Patreon if you want access to exclusive content. I know some of you love everything VIP. I certainly do. And I'll see you guys soon. Love you. Bye.